Hi, welcome to Tutorialspoint. In this video series, we are going to start C programming language. C is a very basic and fundamental programming language for the beginners in order to getting started with the programming language and the basics of it. So, in this video series, we will cover each and every aspects from the basic to the advanced, in which we will see what all we can do while working with the programming language called C. But before getting started with C, in this particular video we will cover what is a programming language and what is the use of it. So basically, if I'll say something about a programming language, so as the name says, it's a language, means it will be used in order to make the communication. A communication with a computer system to tell like what all I want to do in that particular program. So as for the communication, we every time use a language. Like currently, I'm talking with you guys in English. Similarly, I can opt any other language which I know, such as Hindi or English or maybe any other regional or international language. So using those language, we will exchange our thoughts, we will give some instruction which will be provided by the one to whom I'm making the communication. So here we will be communicating with a system, with a machine, so we will be using any programming language. While using a programming language, you will be offered some syntax that you can also relate to the grammar of any particular language. So using an appropriate grammar, you can use any language in order to make a communication. So as here you can see, a computer program is a sequence of instructions written using a computer programming language to perform specific tasks by the computer. So that is what I said, like whenever I'm writing a program, I'm giving some instructions to the machine. And the act of writing a program is called computer programming. Means writing a program, you can also relate it with the coding. You do the coding while writing a program. And whatever you are doing is a programming. A computer programming language is a language which is used to write a computer program. Like nowadays we have a number of languages like C, C++, assembly language we used to work, Java, Python, PHP, C# and many more. So using any of these languages, you can write a program which will communicate with a system. But the issue is, if I'm talking with someone in English and if I want him to do some task which I'm saying, the one important thing is he should also understand my language. So for that, first thing is either I should talk to him in the language he knows, or I require a translator which will translate my language to his language in order to make him understand the task. So initially, we used to write a computer program in the computer language only, that is in the machine language. But learning a machine language is very difficult for a human being, as it is a binary and it will be using some tough codes for writing a single program. But yes, since that language can easily be understood by a system, no translation will be required, so the performance will be better. But practically, writing a program in a machine language is not that easy. So we started working with some mnemonics, which is the English type word, to give some instructions. But in the language like assembly, we used to work with mnemonics. But even there, we have a big list of all the mnemonics in order to perform a single task. So keeping all the mnemonics in our mind is again a big challenge for a programmer. So what we used to do, we started working with the computer programming languages. But if we are using C or C++ or any other programming language, even if we are working with assembly, so we need to make these languages understood by a computer, and for that we require a translator. So what we will do, as here you can see, for the languages like where we use something called scripting like PHP, Python, Perl, we will have some interpreter. An interpreter will translate the code with the machine code, and after that it will be able to make the execution. But for the languages like C, C++ or Java, we have something called compiler. A compiler will compile the complete code, means they translate the complete code to the machine language, and if everything is syntactically fine, after a successful compilation, you will be able to execute the code. When you use the interpreter, along with the translation, it will keep on executing the code. But here, first of all, compiler will compile the complete code and will save the compiled result in a separate file, which will be carrying the machine or binary language in case of C or C++. But if it is about Java, the compiler will compile the complete code and will save in a class file which would be carrying the byte code. Similarly, for the different languages, we have different outputs. Suppose if you are working with .NET, after the compilation, you will be getting the MSIL, that is Microsoft Intermediate Language. So every time when you will write a program, you will use a translator, either an interpreter for the scripting languages or any compiler, a specific compiler for the specific programming language. When we will start working practically with C language, I'll show you how to make such compilations to execute a program. So basically, C language is developed by Dennis McAllister Ritchie in 1973. Basically, he started working on C language from 1969 in AT&T Bell Lab, Chicago, and by 1973, he was able to successfully create the C language. In 1978, along with Brian Kernighan, he wrote the first book which was used to learn C language for the users. That is also called KNR Standards, where KNR stands for Kernighan and Ritchie. Now, nowadays, if you'll talk about any Unix-based operating system, the kernel of all the operating systems have been written in C language. Along with that, all the applications, I should say major of the applications, have been written in C language only. But apart from that, let's cover some more facts about C language. Basically, C language was created to rewrite the operating system Unix. Earlier, if I want to update the operating system Unix, that was a bit tricky task, that was not an easy task to perform. But after creating the C language, the code, the execution of Unix operating system was become even smoother. Earlier, it was written in assembly, but as I said in the introduction in the previous video, learning the mnemonics of assembly is not that easy. The Unix OS was totally written in C by 1973, means by 1973 it was created, the C language was created, and then after, whenever the operating system got rewritten, it was rewritten by C language only. Dennis Ritchie created the C language as the successor of B language, which was generated in 1970. C language was standardized by ANSI in 1988, and nowadays all the popular operating systems like Linux based operating systems like Fedora, Ubuntu or Linux is written in C language. Apart from that, RDBMS, MySQL have been written in C as well. Now the question comes, why should we go for C nowadays when we have so many advanced programming languages like Java, C#, .NET, VB.NET? So basically, if I'll talk about any other programming language, they can be used for the application development such as Windows or web. But if I'll talk about system programming, means if you're creating something core in the system, let's say kernel of the operating system. So such applications can be found by C or C++ like languages, because these are the language which directly communicates with the system, means they doesn't have any intermediate in order to make a communication with the kernel of operating system. So it is used as the system development work, for the system development work, that is system programming. So since, as I said, C language directly makes a communication with the machine, so that also makes the execution faster, because there is no intermediate, whatever you will write will be directly executed. That also brings one responsibility to the developer that he should not write any code which may affect the memory or hardware of the system. So, in other words, the system programming is much away advanced than any application development. Apart from that, nowadays C is used for the creating the language compilers, operating systems, all the modern programs. Maybe if you are working with the applications like embedded, where you need to give the instructions to some hardware, even there you will find that C language is being used. Otherwise, databases are also written in C language. So these are all the basics and the benefits of working with C language. We will cover the environment setup. So for getting started with the implementation of C programming language, we require a couple of things. One is a text editor, which we will use for writing the basic C program, and a compiler in order to compile the code which we have written in the text editor. So doesn't matter in which operating system you are working, you will get the valid version of text editor and the compiler. So let's get started with Unix operating system. So if you have any Unix based or Linux operating system in your machine, first of all you will have to come to the command line and you will have to check with the GCC command, where GCC stands for the GNU Compilers Collection, which will provide you the authentic C compiler. So GCC-V to check the version of that. If it is installed, then you will get something like that in the as a result. But if it is not, it will not give you anything in the return, so that you can go in this particular location, that is gcc.gnu.org/install, where you will find the genuine copy of the GCC compiler of C language, and then after you can get started with the implementation. If you are working on Mac operating system, in that case you can simply go to the official website of Apple for getting the Xcodes. For that you have the URL here, like developer.apple.com/technologies/tools. Or if you are working on Windows operating system, then you can go to the sourceforge.net website, and there you will find it under projects and Orwell Dev CPP. So once you get the setup, you can just make the installation. The wizard will be very simple, which will not cause you any difficulty for installing. And once you are done with that, you can start writing the code. If you don't want to do such things and doesn't matter in which operating system you are working, you can directly come to the Tutorialspoint website, and in the top you will find something called Coding Ground. Once you reach there, you can choose the C environment, and there you will find this text editor. Once you will write the code, you can click on compile. If there is any error, the errors will be displayed here, and to execute you will click on execute, and again the output will be here in this terminal. So this is how in any ways you can start working with the implementation of C. We will start working with the code of C language. So basically, whenever you will write a basic code of C language, that will be a combination of such things. For example, first of all, there will be a preprocessor command. As the name says, it is a preprocessor. That means such statement will execute even before the actual processing will be started. So such statements will be started with the hash symbol, as here you can see hash include, and in the angular brackets there is stdio.h. So this stdio.h is basically the standard header file to perform the input and output operations. But we require that this particular header file should be included in our program before the actual compilation will start. So that's why we call it preprocessor command, or you can also call it preprocessor directive. After that, functions. Function is basically something which will do a specific task. But even if you are not creating a very big program, at least one function should be there with the name main. So whenever you will start the execution of your program, This main function will be the first which will be executed, and if there are some more functions, you will be required to call them in order to execute. Variables. Variables is something which will be used for storing the values. In this example you will not find one, but definitely I'll show you once we start working the practical. Statements and expressions. Like for example, if you are taking a couple of numbers from the user and you want to sum them up or you want to do some operations with them, so for that you will be writing some expressions. And comments. Comment is something which will never get compiled or executed, but it will always be there for giving some information to the developer. So as here you can see, this is a comment. This is a multi-line comment. Basically, whenever you want to start a comment, you can write a slash, forward slash and asterisk, and then for any number of line you can keep on writing the comment, and at the end you will close it with the asterisk and forward slash symbol. If you want to create a single line comment, then generally you do double forward slashes. That will create a one line comment. So let's write our first program in the editor which we have downloaded as per the previous video of environment setup, and see how can we start the implementation of the basic program written in C language. So as here we are working in a Windows machine, let's find how we can start writing a basic program using dev C++. In environment setup, we have discussed the different operating systems and different softwares for that, and similarly you will be having the same software in the different operating system and you can start writing the codes. After this, I will show you how we can use the coding ground for writing a basic C application. So let's get started and come in the start menu where I have already installed dev C++ here. So I'll just open this, and here for creating a new project, what I'll do, I'll simply come to the file, new, and a project. Inside a project you can create multiple program files. So here I will just take one console application in C as a C project. Alright, so here we have two options, either C or C++. Like currently we are going through C only, so let's continue with that. And here I'll give it a name like Tutorialspoint underscore sample code. So let's say OK. And here I have to give a location, so I'm saving it in my documents. Let's save it, and here you will get something called a code file, that is main.c. So let's save it before making any changes. Alright, so I already had, so I just replaced that, and now inside this you can start writing the code. As in the theory just now we discussed about the preprocessor directives, so here you can find hash include stdio.h, similarly hash include stdlib.h. So these are the two header files which will be included, and they contain the prototype of the predefined functions which we will use during the execution of the program. Along with that, whenever it will be the compilation will be started, this will start before the actual compilation. Alright, means these are preprocessor, that's why we call it preprocessor, because they will be included in the file, and whatever the syntax inside this, all will be included in this main.c, and then the compiler will compile it in the object file. Similarly, as many as header files you will include, all will be treated in a very same way. Now inside this you can find there is a comment. So as we just discussed about the comment, multi-line comment, which starts with slash asterisk and ends with asterisk slash. So if you will even divide this into multiple lines, it will be fine, but if it is a single line comment, you can use double slash and you can write this is a comment. So this is a single line comment which we have used. If I will try to split it in multiple lines, it will give me an error. As you can see, it is not considered, this word is not considered as the comment. So here what we will do after the comment, you can see like we have a main method whatever program you will write in a basic C program, you will surely get a main method inside which you will write the code. So whatever code you will write, it will execute as soon as the execution of this program will be started. Now, like for example, I simply want to give a message hi. So here I will use printf, which is a predefined method provided by stdio.h header file. So inside this I will print a string which I will put inside double quotations. So just say hi, welcome to C. Alright, so let's save it. And for execution, what you can do, you can come here, you can find F9 is for compile, F10 is for run, F11 is for compile and run. Alright, so let's say F9, it will do the compilation process. After this, we will get the object file which will be executed as soon as I will say run. Alright, so here you can find the message, hi, welcome to C training from Tutorialspoint. And since at the end you can see we have returned 0 to whom? To the operating system, because it is the one who is calling this main method. So while returning 0, it notifies like the program is terminated properly. Similarly, you can also use void keyword, which we will not recommend much. But yes, after that you will not pass any particular value, because void means it's not having any value. So let's compile and execute pressing F11, and now you can see you will get a random value, whatever value you will get here, right? So that's why we will try to put it integer. Even if you will not put anything, by default it will be considered integer, and then in that case you can just return a 0 value. So this is how you can start writing a basic C program in Dev C++. We will cover the syntax in a great detail. So let's get started with this same program which we have seen in the previous video also. Here you can observe few things, like most of the statements are getting terminated by a semicolon. When we start writing a variable, how can we give a name to a variable, and such things will be covered in this video. So let's get started with the semicolon thing first, as the semicolon is used to terminate a set of statement. Means here, as you can see, after printf I have terminated that with a semicolon. That means this is the end of this command, and after that whatever you will write, whether in the same line or in the next line, that will be treated as the different command for the compiler. But generally after semicolon we will come to the next line in order to make it more readable for the humans. After that, if I want to define some constant or variable in order to store some values in my program, we should name one identifier. Identifier is something, a name which will be used for identifying a specific variable or a constant. So that name must begin with the special character underscore or with any normal character like ABCD. So as here you can see, some names are available, right? If I'm talking about any special character, I will not use anything apart from the underscore, whether you want to use this underscore in the mid or in the beginning. After that, if you want to use any number also, you can use it after some characters, like here bond 7 car underscore 2, but you cannot start a name with the number, like here 1 2 3 5.8 height. That should not be there. Apart from that, there should be no space in the name. There should not be any special character like dollar or decimal. So if I talk about the special character, as I said, only underscore will be accepted. So these are the basic things which you should keep in your mind while giving the name to any identifier. Now let's talk about some keywords. So in C language we have 32 keywords which would be having some specific task. Some of them are for the data types, some of them for returning, some of them for the control statements, like that. For example, here you can see for is a loop, right? If statement, do, while, these are the basic control statements. Similarly, you can also find the data type like double, integer, long, float. So these are few things. So overall we have 32 keywords in C language. As we'll keep on proceeding, we will see the different usage of the different keywords. As so far in the code you can observe, like here we have used int, right? So int is a keyword, return is a keyword. So we will use such keywords for the different purposes. Now let's talk about white spaces. White spaces is basically used in order to make your code readable. For example, when you are done with one line, after the semicolon you press an enter for a new line, so that when you will read, when any developer or any human will read the code, it will be easier for him to understand. Similarly, you can also use the tab indentation in order to make your code more readable and more clear. As here you can see, fruit is equal to apples plus oranges. Here in between you can find some white spaces again, some spaces are there. So it is all for the readability purpose. It is not essential. White space is not essential anywhere, but wherever we will use, it will be for the readability purpose only. So this is about the basic syntax of C languages. We will discuss something about the comments. Basically, when we use a comment in a program code, it is for the user only, means a developer who is writing the code. Suppose nowadays I'm working in a company and I'm writing few code, and later when I leave this company, some other developer will come and he may use my same code. So if I have used some comments in order to explain my code, it will be easier for the other guy to understand. But a comment will never be compiled and it will never be executed. So for writing a comment, if it is a single line comment, means if you want to make a single line as a comment which you don't want to execute, so you can use a double slash, and for the multi-line comment, that will start with this slash and asterisk and it will end with asterisk and slash like this. Alright. So basically here you can see there is one more example of using a comment where I have started with this one and finished up with this. It doesn't matter whether you are using this thing for one line or multiple line, but double slashes will strictly be used for one line only. So as in our previous videos, we have already discussed about the comments, so that is the same thing it will be doing whenever you are writing a code in C language. So if I want to include the comments in this particular program, as we have already done that, but even if I want, I can do that inside my executable code, that is inside the main. So for the single line comment, as I said, double slash will be doing that. So let's see a comment like printing the message. Alright, and if you want to write a multi-line comment, you will simply say slash asterisk and will end with asterisk slash. And inside this you can write any message like returning 0 from the program. Alright, so if you will compile this or execute this, it is not going to make any differences in the output. As I said, like comments will never be compiled or executed. We will discuss about escape sequences. Basically, while discussing the string constants, we have gone through an overview of this escape sequence, but here we will have a deeper look on them. As here you can see a list of all the escape sequences which always starts with a backslash, and here they have the different meaning. Like for example, if I want to print a backslash, I will use double slashes. Similarly, to print a single quote or double quote, I will simply put a backslash symbol before them. Slash A will be a beep symbol. If you want to give an alert message, you can use a slash A before that. Similarly, backspace for slash B, form feed for slash B, new line. If you want to make a new line, if you want to break a line while printing anything, you can use slash N, slash R for carriage return, /T for tab space, and /V for a vertical tab, right? If you want to give a gap vertically. And if you want to put the if you want to print any octal value, then you can go for the /000, octal number of 1, 2, 3 digits. So here we also have an example where we have used so many escape sequences, but rather than discussing this program here, let's go to system and try it practically. So for the escape sequences, here you can see I have used a lot of backslashes. So let's start with this one. Like for printing this double quotes inside printf or inside any other method which prints a string, you can just put a slash and then double quote. It will enable you to print the double quote symbol. Similarly, I wanted to enclose this a character inside the double quotes, so at both the ends I have put slash double quotes and then slash double quotes, which will print this a inside these double quotations. Right after that, I have used slash t, which will give a tab space. Then b character will be there. Then after that I have used slash n, which will break the line. Similarly, here also you can see c and then slash and d. So c and d will be printed in a different lines. Now here you can see I have used backslash, that is slash b. So first you will write a, then it will do a backspace, sorry, not a backslash but backspace. So as soon as you will write a and then backspace, so what it will do, it will delete that character a, and then after that I will write a space and b. So when I will execute, you can see like there is no a in the last one, but one space and b is there. If I will remove this backslash b, means if I'll remove this backspace, then I will see a and b. But to remove this backspace, you can use this slash b. Similarly, we do have some more escape sequences. Like if I want to print the question mark, I can do it directly as well, but using slash also. Next is let's line break. After that, if I want to print the single quotes, again I can put it like this. And similarly, if I want to print the slash itself, I can print a double slash. So it will enable us to print a single slash. So like here you can see question mark, then single quotes and then a slash. So this is how you can simply use this backslash as a escape sequence, and then after you can put any appropriate character for a meaningful sequence. We will cover data types. Basically, to make any programming language type safe, we require a data type which will tell the type of incoming data. So basically in .NET framework, we have 4 predefined data types, that is integer, float, char and double. So here, first of all, we will discuss what are the data types. So as I said, it will tell the type of incoming value. Like if I am going to define an identifier that is either variable or a constant, so we will have to specify a type. Similarly, by the time any method is returning a value, we are going to tell like which kind of value it is returning. Similarly, when you are passing a parameter in a method call, you will again have to specify which type of value you are expecting. So whenever there is a talk of data, we will use a data type to tell the type of that part. So as I said, like basically we have 2 data types. One is for the integer values, means non-decimal numbers. Other one are the floating numbers, means a number with a decimal value. Void is a data type which is used as a return type of a method. You will not define any variable of void type, but whenever you are defining a method which is not returning anything to any other method, then we will use this void data type. Similarly, we do have something called enums. Enums is basically here to give a numerical equivalent to any character value. For example, if I want to fix, like if I'm asking any user a particular day of joining or any particular thing, so I want only some particular set of strings can be chosen. So what I can do, I can create an enum and will give a numerical equivalent to every day which we have in a month. Apart from that, we do have some derived data types also, like arrays, pointers, structures, union, and functions. So basically pointers will be here for storing the address of the variable. We will discuss about them. Array means when you want to store the similar values in a large scale, means you want to make a collection of such values, you can go for the arrays. Similarly, structures, unions are some customized data types which we will discuss in our coming videos. So let's quickly see practically how can we define the variables of various data types. So inside this main method, if I want to define any variable of a specific data type, what can I do is I can simply use the name of the data type. For example, here I have used int, and after that I can just give the name of the identifier through which I can use it further in this program. For example, if I want to define a variable of integer type and with the name var, here I used int var, and after that I can terminate it with a semicolon. So using semicolon you can terminate any particular statement. Along with that, if you want to initialize it with any particular value, you can also assign any integer value, as integer will store only a non-decimal numbers. So here I'll make sure that I'm not passing any decimal numbers. But if there is a double or float type of variable, so in that way I can also pass any decimal value like this. And similarly, if it is a character, I will use the char, so var c is equal to, and for character I will always use a single quotation inside which I will put a character, whether that could be a special character or a normal character. So like this I can define the variables of various data type, and if required I will also initialize them in line. We will discuss about a void data type. As in the previous video of data types we have discussed, like when there is no value we will use void data type. So that is what it means. So basically whenever you are defining a function in which you are not returning anything, you can mark the return type as void. Similarly, if you don't want to pass any parameter while making a method call, you can pass the void as well. But even if you will not pass anything, by default it will be void. Similarly, by the time we will start working with pointers, we will see what is a void pointer. Basically it can store the address of any type of value, but you will not be able to do any arithmetic. But we will discuss about such things in a great detail in a coming videos when we will discuss about the pointers. So now, as I said in the previous video as well, you cannot define a variable of void type. So this one is an invalid statement. Now let's see how to use the void as a return type. So here as you can see in int main, if I'm specifying like the return type of a function is int, at the end I'm returning a 0 from the method. But if I will say void main, means I don't want to return anything, and at the end you can see like I have just used return. Even if I want to skip, I can do that if it is a last statement. But even after the return keyword, as you can see here, I have not specified any particular value of any particular type. So this is how this void works. So let's see an example quickly to compare the functionality of a void and a non-void return type of any function. So as here you can see, like right now I have written a main method where the return type is integer. So at the end you can observe like here I have passed the value called 0, since this main method is returning an integer. So every time when I will execute this particular program, you can see this is main returning an integer. That's the message I printed, and here you can also observe the return value is 0. But as I said, if I'll use void, I will not be allowed to pass any type of value during the return. So if I'll execute it now, alright, here you can see like it is returning 25. But here you can also see like it's returning a warning. So I will just remove this particular value from here,
and now I'll not specify any kind of value. Return can be used in any particular program in order to terminate the function. But now when I will execute, you see there is no warning, no errors are there, and still it is returning 25. So this value is not now in our control. So whenever you want to control the value that is returned by a method, you will use the data type, that particular return type out here, except void, and then after return you will pass the value of that specific data type as well.
Hi, as in the previous videos we have already discussed about the data types, where we observed like we have 4 keywords for defining the basic data types in C language, that is char, int, float and double. But if you want to make some slight changes on these data types, you can also use the type modifier in order to make some small changes. For example, here we have 4 different type modifiers such as short, long, signed and unsigned. So if you want to take only signed values or unsigned values both, then you will go for signed. But in case you only looking for the positive numbers, means no minus sign would be there, then you can make it unsigned. Similarly, there will be 2 flavors for any data type, that is short or long. Obviously, the limit of long will be more than the short, and obviously the size will also be more in case of long. So as I said, like if I'll talk about integer, so integer will occupy 2 or 4 bytes. By default in C it is considered as the long one, so it will take, if it is by default long, then because it is dependent on the different compilers. So if by default is short int, then it will occupy 2 bytes. But if you will use long int, then it will occupy 4 bytes, and obviously accordingly the limit will also be affected. Similarly, if you want to go for it signed or unsigned, then it will again make a difference. For example, if it is a signed integer which is by default, then in that particular case the limit will be this, means the lower limit, as you can observe, is in negative, there is a minus symbol. But if you will say unsigned integer, then the limit will start from the 0 and then it will go ahead, as you can see. So as I said, these 4 type modifiers can help us in modifying the basic features of a data type. So let's see quickly practically how these type modifiers works.
So in this program you can see like I have defined a variable int I, and after that I have used various modifiers along with it. For example, by default when I say int I, so it will be long. So if I want to make some changes, it will be short int, means it will be consuming 2 bytes, and long int, which is by default. So you can see like the maximum value which I have stored inside it is same. Similarly, whenever you define any integer, it is signed by default. If you want, you can use the unsigned modifier along with that in order to make it unsigned. So this is the maximum value. So if I'll execute these, and after that, after printing the values, you can see I have also printed the size of all the variables here. So as you can see here, by default integer is consuming 4 bytes, and if I'll make it short, it will be 2 bytes. By default an integer is long, so when I'm using long int, it will be consuming the same memory, and for sign and unsigned the memory amount will remain same. So as here you can see again it's consuming 4 bytes only, and these are the values which you can store in any particular data type, which is the maximum value. If you will exceed any of that, for example if I will say it plus 1 like 68 or 48, so let's execute it again, you will notice like it will get incremented by 1, but it will go on the left hand side of the scale, means now it will be containing the minus values. Alright, so for example if I'll make it 49, then the value will be changed accordingly. Alright, so as you will move on this scale, it will start from the left to right. In the mid you will be having some 0. But in case of unsigned, the minimum value which you can store will be 0. It will not be able to store any negative values. So this is how you can use these different modifiers along with the data types like float, double, int and character.
We will cover variables. As we already know now about the type modifiers and the data type, using them we can define a variable. So basically here we will see how to define a variable. Variable means it's a data member, it will store some data inside it, and in the programming we will be able to change the value. So whenever you define a variable, first of all you will have to specify the type and then the name of the variable. We have already discussed in our basic syntax chapter like how to name a variable, how to name an identifier. So the same logics will be applied here as well while naming your variable. So after specifying your data type, that is int or float, whatever, you can write the name. If there are multiple, you can simply separate them with a comma, but all the variable will be of the same data type. Now let's see how we can do that. Like for example, here you can see int d is equal to 3 comma f is equal to 5. So here what I'm doing, I'm just initializing it in line, means by the time I'm defining it, I'm assigning the value as well. So as soon as the execution will begin, the value will be assigned. Similarly, for defining any double type, we can pass a decimal value. If we are working with the character value, we will pass the value in the single quotes. So this is how we can start working with the variable. It is not essential that you initialize a variable in line like this. You can just define and later you can also take the values from the user using the methods like scanf and many more. So let's see practically how to work with the variables for inline initialization as well as for taking the value from the user.
So now, as we have already discussed while working with the data types like how to define the variables, so here I will define some variables like integer, float, double and char. So if you want, as we have already discussed, you can initialize these variables in line like this, and later if you want you can print the values. For example, if I want to print the value of the integer, I can use the format specifier for the integer, that is %d, that's for the decimal numbers, and then after I'll print the value of a, terminating it with the semicolon. So when I'll execute this, it will give me the value, that is 10. Similarly, you can initialize all the different kind of data types accordingly. Like if it's a character, I will put it in the single quotes. But if required, I can also take the value from the user during the execution of the program. For that, right now we are going to discuss a method called scanf. When you say scanf, means you are scanning the value which is in a format. Alright, so scanf and printf, in both, f stands for the formatted input and outputs, where we specify the format specifiers like this. So in case you want to take the value for the integer, I will use %d again for it, or %i as well, and then %a, where this ampersand stands for the address of, means whenever you define a variable, it allocates a memory having a particular address. So whenever a user will give some value, it will be sent to the particular address, so that that particular value which is taken by the user will be assigned to this variable. And while printing, I will not use this ampersand symbol here because it will print the address of that particular variable rather than the value. So now let's execute it again. So first of all, I will enter some value like 101, and later that will get printed. So this is how you can do it for all the type of variables. For example, if I want to take the value of any float type, so for that I have %f format specifier, and again followed with the %f. Alright, and later I will print it like printf, and inside I will use the same format specifier %f and then the value of that particular variable. And let me do it for double and char as well. So now here I have written the code along with breaking the line every time you will print the value. So %d is the format specifier, or %i is the format specifier for the integer, while for f, for the float, you can use %f. Same %f can be used for double as well, because both carries the decimal values, and whenever you take the value for a float, internally it is promoted as double. And later %c is used for the character type. So let's execute this one, and here as soon as I will take the value, first value will be for integer, that got printed. The next value will be for the float, so here I will use the float value. It can take up to 6 decimal places, so that got printed. After that I can pass the value for the double, so that got printed as well. But you see, like, I can't print a value for the character. Even as soon as I entered the value for the double, that program got terminated and it never asked me for the value for a character. Because whenever you take the value for a character, it will take the values which is there in the buffer. So what I'll have to do, I will call a method called fflush, and I will flush all the memory, all the values which are there in the standard input stream. So let's re-execute this one. So I'll again start with the integer type value like 101, then a float 102.1234556. Alright, 6 digit values. Then after there is a double, and now it is accepting a value as well. So I'll enter a character, let's such as C, and then that will get printed. So this is how you can define the variable of various types using the different data types or the type modifiers, and then you can start with taking and printing the values.
As in the previous video we have seen how to define a variable and how can we change the value of a variable once the execution is started. But in case of constants, we will not be able to change the value of a constant once the execution is started. So by the time you are declaring the variable, or sorry, I should say constant, by the time you are defining a constant, you should initialize that on the spot, and later you can continue with the same value itself. And for that you can also go for the const keyword. That const keyword will allow you for the constant. We can also use a preprocessor directive which is #define for define the constants. We are going to have a look on Lvalue and Rvalue. Basically, whenever we use an equals to operator for assigning a value in a constant or in a variable, at that particular time we should take care how these Lvalue means the value on the left hand side and this Rvalue means the value on the right hand side is going on. So basically, for a successful assignment we should put the variable on the left hand side. So as you can see here, a is equal to 20. So this is the Lvalue and this one is the Rvalue. So in the Lvalue means on the left hand side we only have a variable, while on the right hand side we can have a constant, we can have a variable, we can have an expression which is evaluating a value. So ultimately the value will come on the left hand side, so make sure it is a variable. But if you are defining a constant, at that particular time you can have the name of a constant on the left hand side, but that is the only exception. After the constant is defined, even in the next line you cannot place the constant identifier on the left hand side of the assignment. As here you can see 10 and 20 both are a constant figures, so you cannot place the constant on the left hand side. It will give you an error, that is Lvalue required. So as I said, in the Lvalue means the left hand side will be an variable only. So let's see practically how we should go for such assignment tasks.
So now as you can see here, I have defined 3 variables like int a, b and c. So if I want to initialize them with a value, on the left hand side as you can see I have placed a variable and along with a value on the right hand side. So this one is a constant while this one is a variable. Again, if I want the similar thing I can do that also. Again, on the left hand side I have b, which is a variable, while on the right hand side I have a constant figure. But if I'll try to do something in reverse like 200 is equal to b, then this will be an invalid operation. So as soon as I will compile this, it will show me the error in this particular line, that is L value required, means on the left hand side I cannot place the constant, rather it should be a variable. Similarly, if I will say C is equal to A plus B, again this is a valid operation because on the right hand side I can pass an expression, I can pass any variable, I can pass a constant value. But on the left hand side it must be a variable which will take the value, because if I'll talk about equals to, it will assign the value from right hand side to left hand side. So even this one is a valid operation. So if I'll try to print the value of C, I will get the value of the total of A and B, that is 101 plus 200, that is 301. So let's check it out. And as soon as I'll execute this, we will see 301 as the output. But now if I'll try to do something in reverse, like suppose A plus B is equal to C, again that is going to be an invalid operation because it will say L value required, because on the right, left hand side I cannot have any expression. So as now we know it very clearly, like whenever you are doing any assignment thing on the left hand side, we must put a variable only.
We will cover about integer constants, as we already know what a constant is and how can we define a constant identifier. But in this video we will have a look on those things which we can assign on any particular integer type of value. So basically whatever you will write on the right hand side of the equal operator, that is a constant or a variable or an expression. But here we will see about the constants figure only. As in the integer, apart from the normal numbers which you can write like 1, 2, 3 means any whole number, you can also supply the values like the decimal, octal and hexadecimal. So in case you want to write any normal number, you can write like this, like here 212 is a normal whole number. But if you will write the alphabets like U and L, it will be like the unsigned or long numbers, and you can write them like this, like 215U. So this is also a valid value. Similarly, in case you want to write any hexadecimal code or hexadecimal value, you can start that by 0x, as 0x suffix is for the hexadecimal. So whenever you will write a literal integer values, you can do them like that. For example, U is for unsigned, L is for long, and similarly 0x means either small x or capital X is for the hexadecimal. If you start the value from 0 only, then that is the octal value, as here this is not the valid octal value, because here you can see 8 in octal values, 8 will not be a part of that. But still, if you want to start an octal value, you can prefix the 0 in before the actual value. So this is how you can start writing any integer constant. So let's see how can we assign any integer with the hexadecimal or octal values practically.
So for passing a constant integer value to any integer kind of variable, let's see what all kind of value we can pass. Like here you can see, first of all I have just passed a normal integer value, that is 212, which is the normal number, and obviously we can assign that particular value to any integer. But if you want, you can also specify the modifiers after that, that is U and L, that is U for unsigned and L for long if required. Similarly, if you want, you can also pass the hexadecimal value, which will start from 0x, and then after you can assign the value to this integer. And for assigning any octal kind of value, you can just begin the value with 0. Now you can generally, as you do, you can simply convert these values of hexadecimal and octal type to the binary digits, and when you will execute that, you will just get the same outputs. Like here, this is 355, this is 531, this is 215 unsigned long, and this one is 212. So this is how you can pass these kind of integer constants value to any variable or constant identifier of integer type.
We will cover about floating point constants. As whenever we define an identifier, either variable or constant of float type, we may initialize them with a particular value on the right hand side of the assignment operator. So whenever you are assigning it with a value which we can also call the floating literal, so how and what all we can write up to there. So a floating point literal has an integer part, means the whole number part. After that you can put a decimal, means as we know floating value also takes the decimal numbers. A fractional part and an exponential part. So exponent means that will be represented by small or capital E. So whenever you want to do like that, here as you can see 3.159. So that is what? That is a fractional number, that is a decimal number. So you can simply assign such values for any fraction, for any floating value. Similarly, here you can find it is the combined exponential expression, like it is mentioned E out here and L, that means long. So it is a complete exponential form which you can assign in any floating value. But if you don't have any complete exponential, means as here you can see it is not a complete one. Here we have written F, that is for float, but there is nothing like a decimal value. And here after decimal we started with the exponential, which is again the invalid value for a floating number. So you can use some valid values like them to initialize any fractional number for a floating point. So let's see practically what all we can pass in a fractional number in float type of variable.
So as here you can see, for floating numbers I can either assign a decimal value like this, where you can see after this float variable on the right hand side we have passed something in decimals. Float values can also take a non-decimal number, but while execution it will show you the zeros up to 6 decimal places. So here I will assign the value, as you can see I have passed up to 5 decimal places like 14159. So by default when it will be printed it will take 0 at the end. Similarly, we can also pass a valid exponential expression like this. As here you can see, after the same value I have passed something E, that is the exponential, and after that the 5L, where L represents the long. So in either cases when I will execute, as you can see, like both values are equal, so when I print the value both will get the same values. But for such statements, these are the incomplete exponential statements, and whenever you will try to execute such statements it will definitely give you the errors. So for float there are two things, either pass a decimal value or a valid exponential series.
We will cover about character constants. If we are writing a simple program and if I want to define any identifier, either variable or constant of character type, we may initialize that with any value on the right hand side of the assignment operator, which is equals to. So by the time I am writing any character literal, I should keep the value in the single quotes. Apart from that, you can also write the numbers for any character value from 0 to 255. But here we will be focusing only on the character value, and for that we will put the value inside the single quotation, that is like this, quotes and then a single character only. That could be any number also or any special character as well. But the thing is, we must put it inside single quotes. Apart from that, we can also use some escape sequences as a character literal, like /t for tab space, /b for backspace, /a for the beep symbol, /n for the new line, and many more. So here, as you can see, in the printf, I have started it with the /t. So in the very beginning, it will give a tab space in the output. And then he said will be like normal text, /n is for the new line. And if I want to print double quotes inside printf, like here I am starting with double quotes, here it's finishing with double quotes. But if I want to print that, I will have to prefix a slash symbol before the double quotation. So here, as you can observe, here we have the double quote symbol, and before that we have the backslash. So it will enable us to print the double quote symbol. If you will not put a slash symbol, it will be treated like here you have opened the string and here the string is terminated, and then here it will start giving you the compile time error. So I need to tell the compiler like I don't want to close this string right here, rather here I have placed the double quotes in order to print the double quotes in the output. So let's see practically what all we can do for printing and for assigning a character value in a program.
So for a character constant, it's quite straightforward, as we have already discussed in our previous videos, like character values must be closed inside the single quotations. So here what I have done, I have simply taken a char variable called c, and for assigning whatever value I'm going to assign, if it's a character value, I can pass any character inside single quotes. Apart from that, a character can also accept numbers from 0 to 255 if we talk about the unsigned ones, otherwise -128 to 27. So for that, signed or unsigned, you can use the type modifiers. Along with that, while printing, you can also use some escape sequences like /n and /t. These are considered as a single character which will do something special for escape sequencing. Like here, I have used 3 of them, like /n for breaking the line, /t for giving the tab space, and /double quotes for printing the double quotes inside printf. So as soon as I will execute this, you can see first it break the line, then there is a tab space, and then after the double quotes got printed. So this is how you can start dealing with the character constants while working with the character data type.
We will talk about string constants. Basically, whenever we use any method like printf or putS, we pass the double quote symbol inside the parenthesis in order to print a string. So anytime when you want to write a string literal, you will have to enclose the value inside these double quotations. So anything inside a double quote will be treated as a string. In this video particularly, we will not talk about assigning any string value to a variable, as we will cover about the string variable things in the character array in our coming videos. As in C language, we don't have any data types such as a string. So here let's talk about only printing the string value. Like here, you can, if I want to print something like hello dear, so what can I do? I can put it in a straight line like hello dear. Or if I have a big value and I want to split them in the multiple lines, I can continue that by putting a backslash. So this backslash will bring the continuity in the value which you have written. And similarly, if you are not putting any /n or /t, any space or new line thing, you can use multiple printf things also. Like in one printf you will write hello, in another you will write d, and then year. So ultimately all the text will be printed in a same line and the output will remain same. If you want to put any Unicode character, you can put it like by beginning with the /u. Like here, if I want to put this pound symbol, so I can simply say /u 20AC, so it will print the pound symbol. Similarly, we do have the different Unicode characters for different symbols. So let's have a practical look over the string values, like how and what all we can do by printing a string value.
So here we will just cover the strings which we use to print using printf, while if I'll talk about the string values assigning in a variable, we will cover that while working with the character arrays. So here what I have done is it's a simple message like hello and world. If you want, you can just print the complete message as a whole. But here just wanted to show you, like, even if I will split the statement into multiple printfs, it will not break the line actually unless I use something like a /n. But if there is a big paragraph which you want to print inside a printf, or if you want to assign it into a something collection like thing or array, you can just make a continuation by putting this slash at the end. So if there's a long paragraph which you want to print, and obviously when you will write them all in a straight line, you may get a scroll bar here or horizontal which will help you out in scrolling the large text, but that will not be readable properly by a developer. So if you want to split the large text in a multiple lines, then in that case you can just end up that line with the backslash. If I will remove that, you will see, like here, now the color, the font color is changed to blue, from blue to black, and now when I'll compile, it will show me the error. But as soon as I will put the backslash at the end, you see now this will be considered as a complete statement, a complete sentence. So when I'll execute it again, you will see that there is no difference in the output. Like in both the cases we are getting hello comma world. Either you are printing it in that way, or if you want to, rather than going for multiple printfs, you can just split the bigger text by using this backslash.
We'll see how to define an identifier as a constant using the const keyword. So basically the implementation will be quite simple. Here we will use a const keyword before defining any identifier, as we used to do. Like earlier we said, like int var, means then var is a variable. Now here just before the data type I will use this const keyword. So let's see practically how to work with the const.
So now using this const keyword, as you can see, initially if I'll remove this const, it will be treated like a variable, means all these identifiers like a, f, d, c will be treated as the const, as a variable. But as soon as I have added the const keyword, you are necessarily required to initialize these values, as after this you will not be able to make any changes into these values, because we have already discussed about the L value and R value, and on the basis of that, on the left hand side there must be a variable, but here this C is not a variable but a constant. So if I will try to compile this particular program, it will give me the error in this particular line saying that is an assignment to a read-only variable C, means it is now a constant, and once it is initialized you will not be able to change it during the execution of this program. So this is how, using the const keyword, you can just define a constant type, and then you can initialize it with the particular value which you want to use throughout the program.
We are going to have a look on the Typedef. Basically, we can use the Typedef keyword for giving an alternate name to a data type. Basically, we will use this Typedef properly by the time we will start working with some complex data types such as union or structures. But here, for a reference only, you can see like we have a data type called char, and using Typedef we are giving it a new alternate name, as it is a syntax like Typedef, then actual type name, and then its new name. So that is what we have done here. Like we have written a byte as an alternate name for char. So here, for defining a variable of character type, I can either go for the char, which is the original one, or the byte keyword. So this byte is not a keyword, basically it's an alternate name. So this ch1 will be of byte type, and whose byte? Byte is char. So ultimately ch1 is of character type. So basically we use this Typedef for giving a smaller or meaningful name to the complex type like structures and union. But in this example, let's see how to implement this Typedef keyword.
So now here in the Typedef example, you can see like I have renamed the data type integer. So here using the typedef keyword, later the actual data type name, that is int, and later I renamed it as integer. So throughout this program, whenever I want, I can use this integer in spite of using int. So here as you can see, int a, so a is of int type. Similarly, b is of integer type, but internally b means integer is also int, so b is of int type. So both are having the same data type. So similarly, when I will sum them up, I can store that inside c, which is of integer type again. That is a, that is int. And for printing this c, which is of integer type, I can go for the same format specify. Means everything is going to be same. It's just you are giving an alternate name for a particular program for a data type. So let's execute this, and there is nothing tricky. You will get the same simple output, that is 10 plus 20 is 30. So whenever you have some complex data type, this is not a very accurate example because obviously int is quite handy for me for using rather than this integer. But by the time we'll start working with the complex data types such as enums or structures or unions, you can simply give them a simpler name by using this typedef, and by the time we'll start working on that, I'll definitely show you how to work with the typedefs.
We are going to cover another very important concept of C language, that is enumerated type, which is nothing but a user defined customized type. So basically, whenever you are writing a program and you are wishing to give a predefined list to the user out of which he can choose any particular value, you can go for the enumerated type. As here you can see, I have defined a couple of enums here. That is, first is boolean. Generally, as we know, we don't have any data type such as boolean in C language. 1 is for true, 0 is for false. But here we can define that. Like how? In the enum boolean, there are a couple of values, no and yes. Whenever you define a series of such values, each value has an integer constant value. So basically that by default starts with a 0, like the first element here would be having 0, then yes is 1. If you would have defined more values, continuously it will be like 2, 3, 4 and so on. But if you want, you can just change the value. For example, if you will initialize like no is equal to 1, so yes will automatically be 2. Means it will be continuously increasing by 1. Enum days. Next one, again Sunday, Monday, Tuesday till Saturday. So by default again the value, the numerical equivalent for Sunday would be 0, Monday 1, Tuesday 2, 3, 4 and so on. But as you can see, now on Friday I have initialized it with 7. So the next value will be automatically 8. If you want, you can initialize the value from here itself, like if you say Sunday is equal to 1, then Monday is 2 and so on. So here when I say that enum boolean flag is a variable name, and here I have assigned yes. So if I'll print the value of flag, then it will print nothing but 1 because it's 0 and here it is 1. So value of flag will be 1 and Thursday will be like 0, 1, 2, 3, 4 for Thursday and 8 for Saturday. Since Friday is 7, so next will be incremented by 1. So rather than seeing here, let's have a practical implementation of enumerated types.
Now here in this implementation of enums, you can observe like I have defined a couple of enums, such as first one is boolean containing the couple of values like no and yes, and one is days which is containing the values from Sunday to Saturday. Alright, so basically whenever I will define a boolean and I'll create a list inside that, it will carry the numerical equivalent. That is, by default it will start from 0, like no will be at 0th position and yes will be 1. Similarly, if you will not specify again here, so Sunday is 0, 1, 2, 3, 4. Alright, so till Thursday it's 4. Then for Friday I explicitly initialize it by 7. So it's 0, then 1, then 2, then 3, then 4, and now it is 7. So next one will be 8. So it will automatically increase the value for the next incoming value, which will be the, as I said, the numerical equivalent. But if you want, you can just change the default values as well. Like for the very first position, I said Sunday is 1, so this will automatically become 2, then 3, 4, 5, and now it is 7 and 8. So here, as you can see, for this flag, which is of enum boolean type, alright, which is having two values, no and yes, if I will initialize it with yes, that means it is 1. So when I will print the value of flag which is containing yes, and that is nothing but 1. Similarly, because I am printing it as the integer, alright. Next is Thursday. For Thursday, I have stored it inside this days enum, then 1, 2, 3, 4, 5. So for Thursday it's 5, and for Saturday it's 8. So let's execute, and here you can see 1, then 5, then 8. 1 is for yes, 5 is for Thursday, and then 8 is for the Saturday. So this is how you can start working with enums, and whenever required you can just use these values directly. Here you will have to be sure, like if you have specified sat, you will use sat only. You will not be able to change it as Saturday or with anything else. So whenever you want to fix for taking the incoming string, and if you want to assign a numerical equivalent for that, you can go for the enums.
Basically, whenever we write a basic program in C language, we define some variables or constants using some data types. If after that I am going through some operation, or if I am writing any expression, the resultant of that expression may be of some other type. So in order to maintain the type, we need to make it a typecasting. So here, as in the example, here we have two values, like sum is 17, count is 5, and if I'll do a division here, so the resultant will be of decimal type. But as you can see, since these two variables are of integer type, the resultant will also be of integer type by default. So to make it of decimal type, we will typecast it in the double. So as here you can see, mean is of double type, but as soon as we will do the typecasting, the resultant, the output will be in the decimal values. So when we will print the value of this mean, you will observe like we are getting that in a decimal form. So let's see practically how to do such typecasting things in practical.
So now let's hear it for the typecasting. As here you can see, I have taken two variables. One is sum having a value 17, and another one is count having value 5. And if I want to find the mean or the average, then I will divide the sum by counts. So here, when I'll divide 17 with 5, it will give me something like 3 point something, alright, means something in decimal. So if I want to store that decimal value, first of all, I will define any appropriate data type such as float or double, and then this result will be of integer type, which will ignore the decimal values. So if I want to take that decimal also, here is what I have done the typecasting. If I will remove this particular part and will see the output, then I can see it is showing me 3.00. But actually this is not the actual result. So what I'll have to do is I will simply type it cast by as a double, and then when I will execute this, you can see you will get 3.4. that is the exact result. So whenever you want to change the particular incoming value to any other type from its default one, you can simply put this particular way, like inside the parenthesis you will put the type which you are looking for. So this is how you can start working with the typecasting.
We will discuss about operators. Basically, whenever you try to do any operation while writing a program in C, you need to write an expression, and that expression is consist of the operators and the operands. For example, if you are trying to sum up two numbers of integer type, then those two variables or constant of integer type is the operand, while the plus symbol which you are using for adding up is the operator. Once the summation is done, you try to assign the value in some other variable. So that variable is again behaving as an operand, and the equals to operator will be the operator. Now here you can see the different kinds of operators which are used for the different purposes. For example, the first one is arithmetic operator, which will be used for any arithmetic operation like plus, minus, multiplication, division. Then we have the relational operator, which is used for the comparison. Means you can compare whether two values are equal or not equal or greater or lesser or anything like that. Then we have the logical operator, which is used to combine the multiple conditions. So here we will be having the binary operators such as AND or, which will combine the two different conditions, and both have their different truth table, which we will discuss while giving a deeper look to the logical operators. Next is bitwise operator, which actually operates on the bits of any value. Whenever you assign a value to the variable, that value is first of all converted in the bits and then gets stored. Then after every time when you read or do any operation, that bit value is converted into decimal and then the operation is done. But while working with the bitwise operator, it is not required to convert the bits value to the decimal value, because the bitwise operators will be directly operating on the bits part. Next is assignment operator. We have already given a look to the assignment operator while working with the Lvalue and Rvalue, but here along with that we will see some more shorthand operators which is required with the assignment operator. Once we are done with all the operators, we will give a look on a different kind of operators which will do some conditional kind of thing, which is the ternary operator. And at last we will see about the operator precedence. Means if we have a complex statement having multiple kind of operators in it, we will have to judge like which operator is going to operate first and who is going to be last. So that thing will be done by operator precedence and operator associativity, which we will discuss at last. We will discuss about arithmetic operators. As in the previous video, we have already given a look on the operators, like what an operator does. So these arithmetic operators which we are going to discuss in this video particularly will help us in doing some arithmetic operation like adding, multiplication, subtracting and division. So here we have some list of operators which we will cover under arithmetic operator. Like plus operator is used for adding two numbers, subtract means hyphen, symbol is used for the subtraction, asterisk symbol is used for multiplying two values, slash means forward slash is used for the division, modulus means this percentage symbol is again used for the division, but it will take the remainder part. When you divide two numbers, one is quotient and another one is the remainder which you get. So this slash symbol will take care of the quotient part, while this modulus symbol will take care of the remainder portion. After that, we do have some shortcut operators, shorthand operators like plus plus and minus minus. Plus plus symbol will increase the value of any numeric variable by 1, while minus minus will decrease the value by 1. Here we have a quick example which you can have a look. Like first of all, I defined a couple of variables like a and b, because most of the operators which we have discussed are the binary operators, means operators having two operands, and one more variable c for storing the result. So first of all, we added two numbers, so 21 and 10 will get added and we will see the value. Similarly, a minus b means the subtraction will be done and again we will see the result. Then a multiplied by b means 21 will be multiplied by 10 and then we will see the result. In line 4, we will see the quotient part of this division. Like if I will divide 21 by 10, I will get 2 in the quotient and 1 in the remainder. So in line 4, when we use the slash symbol, means the division symbol, we will get the quotient part, which is 2, and here in the line 5, when we use the mod symbol, we will get the 1, means the remainder. Then a++, which is the shorthand operator for incrementing the value. But again, they comes in two different varieties. One is post increment, another one is pre-increment. As here you can see, C is equal to A++. So in this operation, two tasks are going on. First is incrementing the value and another one is assigning the value in C. So as I said, it is the post increment, means the increment will be done later, and before the increment will take place, the value of A will be assigned to C. So here you will get means if A is 21, so here C will get 21, and after that the value will be assigned on A. So A will become 22 later. So here when you will print the value, you will find 21. But here again what I did the post decrement, means the assignment will take place before the decrement. So by the time the value of A will be assigned to C, it will be 22, and later the value will be decremented again to 21. So when you will print here, you will get 22. But now remember, the value of A is 21. Now again here you can see ++A. This ++A is pre-increment, means before the assignment of value in C, the value of A will be incremented. So here ++A, that means this 21 will again become 22, the A will become 22, and then the value will be assigned to C. So again in line 8, you will observe that you are getting 22 in the result. And finally in line 9, again you can see pre-decrement. Pre-decrement means the decrement will happen before the assignment. So this 22 will become 21 again, and then the value will be assigned to C, and then you will be able to see the value. So let's have a look on this particular program practically and see by doing it some more changes. So let's have a program now.
So here for implementing the arithmetic operators, here we have defined three variables: A is equal to 23, B is equal to 10, and C, where we will store the result. So here inside, whenever I want to do any arithmetic operation between A and B, I will use the particular operator. As here in the first statement, I have used A plus B, which will actually sum the value of A and B, and then it will be assigned to C. So when you will sum up 21 and 10, it will give you 31, which will be assigned to C, and later you can print that value. Similarly, you can also use the subtraction, that is the hyphen symbol, for subtracting the value of A to B, and if you will do that, so 21 minus 10 will be 11, and then that will be assigned to C. Don't get confused, every time when we are doing any operation, the value of C will be overwritten. Like first of all, it got 31 due to the sum, and later after subtracting the values, the value will be overwrite, and then it will get the difference, that is 11 in this case. And throughout this implementation for these lines, the A and B value will remain same. Now let's take the third one. Still the value of A is 21 and B is 10. So when you will do the product of that, it will give you 210, which will be again assigned to C, overwriting the previous value, and then we will print that. Next is division. So when you will divide the value 21 with 10, in the remainder you will get 1, while in quotient you will get 2. So here in the first part, when I use the slash, that is division operator, it will carry the quotient part and C will get 2, while in the modulus, that is in the percent symbol, it will take the remainder part. So in this particular case, it will get the 1. So if I'll execute, so from line 1 to line 5, what we will get? In line 1 we will get 31, in line 2 we will get 11, in line 3 we will get 210. In line 4 we will get the quotient, that is 2, and in line 5 we will get the remainder, that is 1. So this should be our output so far. So let's execute this and see. For these first 5 lines the output is same, like 31, 11, 210, 2, and then 1. Now let's talk about the increment and decrement operator, that is the shorthand operators. So here you can see, like initially I have used the post increment. When I say post increment, that means out of the two operation means one is assigning the value of a to c and second one is incrementing the value of a. So there are two things which are going on in this statement, out of which the increment will be happening later, means it is a post increment. So before the increment the assignment will be done. So at that particular time the value of a will be assigned to c, the value of c would be 21, because a will be 21 by the time we have assigned the value. But later, as soon as I have assigned the value, after that value will be increased and then a will carry 22, but after assigning the value. So by this statement the value of a will be 22. And again you can see, like this is post decrement. So before the decrement will happen, the assignment will take place. So current value of a is 22 because of this increment which happened later. So the value of c will be 22 in this case, and after that the value will be decreased again to 21. Now in line 8 what it will do is it will be a pre-increment. So before assigning the value to c, the value of a will be incremented. So since after this statement the value got decremented and a again became 21. So now it will first become 22 and then it will be assigned to c. So if I'll print that value, so what will happen? It will say 22. And in the last one what it will do, it is pre-decrement, means before assigning the value we will decrease the value by 1. So first a will become 21 and then it will be assigned to c. So again it will be 21. So let's again execute and see for the last 4 statements whether the output is 21, 22, 22, 21. So you see 21, 22, 22 and then 21. So this is how your arithmetic operations actually gets executed.
We are going to discuss the relational operators. Relational operators are also called comparison operator because they are used to compare a couple of values. Generally, in other programming languages, whenever you do a comparison, they return you a Boolean value that is either true or false. But since in C language we don't have a Boolean type, so they return 1 if the condition is true and 0 if the condition is false. So here you can find these 6 operators are here, that is equals to. When you're comparing two values whether they are equal or not, you will use a double equals to, then not equals to, greater than, less than, greater than equals to, or less than equals to. So here in this particular example we will just check the value in the output, but in our coming videos we will use these values as a Boolean to do some decision making. So let's see a quick program for the implementation of these relational operators.
So now here we can see, like there are the implementation of all the 6 relational operators, that is double equals to, not equals to, greater than equal to, less than equal to, greater than, and less than. So as we have already discussed just now, like whenever you will compare any two values using these operators, in the result you will get 1 or 0, where 1 will represent a true, where 0 represents a false. So as you can see, A is 10, B is 20. So when I will say whether they are equal, so obviously they are not. So here we will get a 0, that is false. Similarly, when we will compare that whether they are not equal, obviously they are not equal, so this condition will be true and it will return me a 1. Similarly, A is 10, B is 20, and when I say A is greater than or equal to B, then obviously it will not be true. So again it will be a 0, while this less than condition will give you a 1, because A is at least less than, if it is not equal, at least it is less than B. And then when you will say A is greater than B, again it will be a false, so a 0. And at last when I will say A is less than B, yes, A is less than B, so it is true. So output should be 0 1 0 1 0 1. So let's execute, and here you can see 0 1 0 1 and 0 1. So this is how these comparison operator works. Now let me give the same value to A as well, and let's see what the changes we will get. So now this will say 1 because A is equal to B this time. A is not equal to B, no, now they are equal, so it will be false. A is greater than or equal to B. A is of course not greater than, but yes, it is equal to B, so this will return a 1. A is less than or equal to B. Again, they are not less than, but yes, they are equal, so again a 1. A is not greater than B and A is not lesser than B, so these two will give you a 0. So now the output will be 1 0 1 1 0 0. So let's execute. So 1 0 1 1 and then 0 0. So this is how your Boolean values will be getting when you will compare two values. And later we will use these values 0 and 1 for executing the loop and for the decision making using the if-else statement.
We will discuss about logical operators. As in the previous video, we covered relational operators which were used to do some conditional things like comparing two values and getting the values like true and false, that is in C, 1 and 0. But if we have multiple conditional things like here, how can we merge them up? So here we will use the logical operators. As here in logical operator, we have the operators like and or, which are used to combine two conditions. If I'll talk about AND operator, it will return a true, that is 1, if both the conditions are true. If any of the condition is false, it will return a 0. Similarly, if I talk about OR operator, it will return a false only when both the conditions are false. But if any of the condition is returning a true, it will return a true, means 1. Similarly, if I'll talk about the NOT operator, this NOT operator is a unary operator which will simply convert a 0 to 1, means a false to true and true to false. So let's see a practical implementation for all these three logical operators.
So for the relational operator AND, here I have taken a variable C which will store the result returned by the AND operator. And as I said earlier several times, like here 1 will represent a true and 0 will represent a false. So accordingly, this AND operator will work, as in the first statement when both the values are 1, so in the resultant you will also get a 1, while if any one of the value, whether the second one or the first one or both, are having 0, so the resultant of AND operator will be a 0. So when I will execute this, you can see only in the first condition it is returning us a 1. After that all the three are having 0. So this is what happens with the AND operator, like it will return a true when both the conditions will be true. But let me now replace this AND operator with the OR in all the places. So now you can see, like I have replaced the AND operator with the OR operator by using the double pipe symbol, and here whenever any one of the condition will be 1, the resultant will be 1. But when both the conditions or both the statements are returning you a 0, then the resultant of OR operator will also be 0. Like here, you can check I have not used any expression or any boolean command here, but I have used the 1 and 0 as the constant figures. But definitely you can pass any expression using the relational operator which will give you a value like 0 or 1. So if I'll execute, I will observe like only in the last, when both the conditions or both the values are 0, the resultant of OR operator is coming 0. Otherwise, in any of the previous statements, you will find 1 as the output, whether both or any one condition is true. But in the very reverse, if I'll do something like, if I will use this exclamation along with these values, let me put exclamation in all the printfs, which is nothing but the not operator. So it will just give you a reverse value. So now all the ones become 0 and 0 becomes 1. So this is how you can work with the logical operators, that is AND, OR and NOT. In the future, we will use these statements in order to pass in any decision making, such as in if statement or in any loop, in order to tell like how many times I want to execute a particular given loop. So this is all about the logical operators.
We will cover bitwise operators. Bitwise operators are the one who directly works on the bits of any particular value. For example, if we have a variable like int a is equal to 1213, so by the time you will store the 1213, that particular value in a variable, so it will firstly be converted into binary and then it will get stored into the memory. So when I will apply any of the bitwise operator, it will directly work on those binary bits. So for example, here we have 0 and 1, that's the binary value that we have. So P and Q are the two variables which are carrying the bits. So if I will use the AND operator, it will, like AND operator in the logical, it will return a 1 only when both are 1. So as here you can see, when both bits are on, both bits are 1, only then it is returning you a 1. Otherwise, in all the situations, it will return a 0. Similarly, this is a bitwise OR, which is again working as same as that of the logical OR operator. That is, it will return a false, means 0, only when both are having 0. If any or both are having 1 in it, it will return you the 1. And the last one is the XOR operator using the caret symbol. So the XOR operator will return you a true when any one of the bit is on. For example, when both the bits are 0 or when both the bits are 1, it will return you a 0. But when it will get a combination of 1 and 0, like 0 1 and 1 0, it will return you a 1. So apart from these three, we do have some more operators like AND or NOT. It is the complement operator. After that, we have the left shift and right shift operator. So let's have a look how these operators basically works. So here, let's say I have a variable int a is equal to 4 and b is equal to 8. So if I'll convert them in a binary, how will I do that? So here we have the 8-bit means 1 byte. Alright, and we know like it will start from 1, 2, 4, 8, 16, 32, 64 and 128. That is for the each block. So if I want to put 4 inside this, I will put a 1 here and remaining will be 0. Similarly, if I will create one more bit for the B, I will put a 1 in 8, remaining will be 0. So now whenever you will perform any operation between A and B, it will be calculated like the particular bits. Like if I will say A and B, so 0 and 0 is 0, again 0 and 0 is 0, 0, right? 1 0 is 0, 1 0 is 0 again, and then like this. So this is all about when you will do any AND operation. Similarly, if you will do OR operation, you will get 1 in these two. But if I will say something about the shift operators, let's say I want to do A left shift 2. So this one is 2. So when I say left shift 2, that means I will shift the value of this 4 to 2 bits left, that is 1, 2, and I will put this 1 over 16. So when I will print the value of A left shift 2, it will bring 16. Similarly, if I will do the right shift operator to 2 bits, again I will shift this 4 into 2 bits right, like 1, 2. So it will give you 1 because this 1 will be shifted to the first place. Similarly, you can have the different values inside A and B, but it will give you the similar output. It means in the same way the value will be calculated. So let's see practically how to implement these bitwise operators.
So now here we can see, like, I have taken the very same values which I have used in the presentation, like A is having 4 and B is having 8, and now after that when I'll do the bitwise AND operation along with that, the bits of A and B will be calculated. So in the case of bitwise AND, when both the bits will be 1, only then the result will be 1, otherwise the result will be 0. So here we can see here in the Excel file, with the help of Excel file, like A is 4, so this will be the bit representation of A, that is 1 will be having in the 4th position, and for B here is 1 where the value will be 8. So you can see, like, nowhere around we are having 1 in both the bits, so the resultant is completely a 0. So in A and B we will get 0 in the output. Similarly, if I'll try to get the OR operation between them, then according to OR operator, I'll get a 1 when any one bit is 1 or both bits are 1. So in the case of A or B, I can find 1 in couple of places, like in 8 and 4. So when 8 and 4 are 1, so in the output I will get a 12 right here. Similarly, when I'll say A left shift 2, that means initially, let me put 0 in both the places, right? So initially the value of A was 4, and as soon as you will shift the bits of A into 4 bits, into 2 bits left, then this 1 will be shifted here and remaining bits will become a 0. So now the current value is 16, so here if I'll observe, the output will be 16, and when I'll do it in the right shift, 2 bits to right shift, then again the initial value was 4. When I will shift 2 bits to right, in this case A right shift 2, then what will happen? It will shift 2 bits to right, that is 1 and 2, so it will become 1, and here this will become a 0. So now here I will get 1. And similarly, when I'll go for the A XOR operation, so in XOR operation the different bits will get 1 and similar bits will get a 0. So here let me bring it to the actual position. Yeah, and now here you can see in this particular bit there is a different bit, that is A is 0 and B is 1, and here again they have the different values, that is A is 1 and B is 0. So these two places will be having 1 and remaining will be 0. So again when I'll sum it up, 8 plus 4, it is 12. So even in here I'll get a 12. So the output should be like 0, 12, 16, 1, 12, and here you can see 0, 12, 16, 1 and 12. So this is how these bitwise operators actually works.
We are going to discuss about the assignment operator. As we have already given a look on this assignment operator while discussing the left hand value and right hand value, Here we will see some more complex statement. As here you can see, apart from this simple equals to operator, we do have some more operators which are nothing but a shorthand operators. For example, if I'll discuss about plus equals to, it will add up two numbers and then the value will be assigned on the left hand side variable. Like here, if I say C plus equals to A, means the C will be added to A and then the value will be assigned to C. Similarly, minus equals plus equals to, for all the things you can see there is a same treatment. So let's see practically how to go for these shorthand operators using the assignment operator.
So in this example, you can easily observe the different working of equals to operator, that is the assignment operator. As first of all, I have taken a value in variable a, and then when I'll say C is equal to a, that means, as we know, the value will travel from right to left and the value of a will be assigned to C. After that, you can see some shorthand operators out here like C plus equals to a, that actually means C is equal to C plus A. That means the value of C and A will get added and the new value, the sum, will be assigned to C. Similarly, again here you can see C is equal to C minus equals to A, that means C is equal to C minus A. Alright, so it is minus A. So this is how they actually work. So for anything which you use, whether it's an arithmetic operator or a bitwise operator, the way of doing the thing will be same. Alright, so if I'll execute this one, you will see the various outputs. Like in the first, when I assigned the value of A in C, C also got the same value, that is 21. Then we added 21 and 21, that becomes 42. Then we subtracted 42 and 21 because A is still 21 here. So that will do 42 minus 21. So at the third line, you again got 21. Now here, since both are 21, when you will product 21 and 21, it will become 441. Again, when you divide 441, because C will get 441, when you will divide 441 with 21, again you will get a 21. And similarly, at the last, when you say C is equal to 200, and then when you will find the modulus, that is the remainder, you will find 11 out of it. So this is about the assignment operator, where you can perform some shorthand operators along with any arithmetic or other operations.
Now, as we have already covered all the types of operator that we have in C language, let's discuss about the operator precedence. In operator precedence, we actually discuss about the sequence in which the various operator will come in action if all the variables are in a same expression. So here we will start with the brackets, means whenever you will put any statement inside a bracket, that will be having the maximum priority, means the precedence. After that, the unary operators such as the not, complement operator, plus plus, minus minus, size of operator for calculating the size, they will be executed. After that, the multiplicative, means multiplication, division, modulus will be executed. Now, right after that, we have the plus and minus. Both are having the same precedence. Similarly, here you can see multiplication, division and modulus. All three are having the same precedence. So if in any of this statement we have the multiple operators of same precedence, then we will go for the associativity. And for the different operators, we have the different associativities. Like for the arithmetic operators, we have the associativity from left to right. Means if there is a statement like A plus B minus C, then both are having the same precedence. So we will go from left to right, means A plus B will be done before B minus C. Similarly, then after we have the shift operator precedence. In relational we will not count the equal and not equal, but anything apart from that like less than equal to, greater than and greater than equal to. After that, we will compare the equality, like whether they are equal using double equals or not equal, means exclamation and then equals. Then after we have bitwise AND, bitwise XOR, bitwise OR, And right after that we do have the logical and, logical or, and conditional, that is, this is the ternary operator. After that we have the shorthand operators like equals to means assignment, including the shorthand like equals to, plus equals, minus equals, which we have already discussed in our just previous video. And after we have the comma operator. So this is the precedence of working with the operators. Now if you get any complex expression, you can use this table for calculating the exact value. For example, here we have the two operators like plus and division. So as we just saw, the precedence of division is greater than precedence of plus. So first of all, 4 will be divided by 2, the result will be 2, and then this 2 will be added to the 5. So this is how, and here as you can see, 5 plus 2 minus 3, plus and minus both have the same precedence level. So here the associativity will be followed. So let's see writing some more complex statement and see how can we achieve the different kind of result using these similar expressions.
So now here you can see for the operator precedence, I have the couple of arithmetic operators here where we have observed that the precedence of division operator is more than plus. So in this particular operation, first of all, the 4 will be divided by 2, that will give us 2, and then that 2 will be added to this 5. So here in the first statement, I will get a 7. Similarly, here you can see like there are a couple of assignments which are arithmetic, and plus and minus are having the same priority, that is same precedence. So when these operators of same precedence will be there in an expression, then the associative will take place, and for the arithmetic, as we discussed, the associative will come from right to left, so from left to right. So first of all, this 5 will be added to 2, and then the result, that is 7 minus 3, will be done. So it will give you 4. And similarly here, since minus is before plus, so first of all 5 minus 3 will be done, that will give you 3, then 3 plus 3 is 6. So this is how you can see there is a output 7, 4 and 6. So 7, 4 and 6 the output. Now let's take a bit complex statement where I will use few more operators. For example, I'll say result is equal to 6 plus 8 divided by 7 greater than 10, and 7 plus 7 is less than 10. Alright, here you can see first of all I have used the brackets, then a slash, that is division, comparison operator and logical operator. So which will do first? So first of all, the precedence of these brackets will be higher. So what it will be here, like 6 plus 8, that is 14 divided by 7 greater than 10, then ampersand. Again 7 plus 7 will be resolved because they are in the brackets. So that is 14 and it is less than 10. So this will be happen first because the parentheses are having the highest priority, the precedence. After that, the arithmetic operators will be in action. So here you see 14 divided by 7 is the arithmetic operation. This will occur, that will give you 2 divided by 10, and 14 is less than 10. So here after this, now there is no arithmetic operator, only the comparison and logical operators are still there. So after that, the comparison operator will be in action, and the first comparison, that is 2 is greater than 10, will give you a 0, means false, and 14 is less than 10, again it will give you a false. Alright, so this logical operator is only thing to do, and 0 will give you a 0. So when I'll execute this in the result, I will find 0. So let's print the value here, printf, and here inside I will print the value of result Let's see what's the output. So here you can see the output is 0 as we observed.